ever wondered what the wind has done for you lately? Well, it might be more than you think. Wind measurements help us make better weather forecasts and track dangerous storms. We can learn how currents affect coastal nutrients and even begin to understand how the atmosphere works and responds to changing climate conditions. But how do you measure the wind at sea? Luckily, we can get a little help from the ocean itself. Wherever the air meets the water, the wind raises waves on the surface. The stronger the wind, the larger the waves, and their direction and speed also tell us about the wind driving them. And the best part, we can see them from space, at least if we know how to look. That's where scatterometry comes in. Scatterometry is a technique for measuring the size and shape of objects by watching how light waves reflect or scatter off of them. Looking at the Earth from space, a scatterometer uses radar to send pulses of light down to the surface and measures how much bounces back. To study ocean winds, we use a very specific kind of light, microwaves. Microwaves have wavelengths between 1 millimeter and 1 meter, and, in case you were wondering, microwave ovens work because those light waves are exactly the right size to agitate the water molecules in your food, heating it up. They're also exactly the right size to tell us about wind-driven ocean waves. The spacing between the waves and the wavelength of the radar are similar, which causes a resonance effect and makes it easier to measure. If the ocean is calm and there aren't any waves, most of the light will bounce right off of it, and none of it will be reflected backwards where the spacecraft can measure it. As the wind rises, though, the waves get taller, and some of it will bounce back in a pattern that's picked up by the detector. That pattern depends on the height and orientation of the wave, so we can use it to figure out the wind speed and direction that caused the waves in the first place. RapidScat is a scatterometer that will be installed on the International Space Station later this year. Hitching a ride with the SpaceX Dragon mission and sharing power, communications, and a stable platform with ISS, this plucky instrument has a knack for making the most of any situation. And this partnership opens some pretty exciting prospects. Other scatterometers pass over a point on the surface at roughly the same time every day. ISS travels in a completely different orbit, which means that RapidScat will be able to measure the wind at different times. That's really important when you're trying to understand how heating from the sun can affect winds and cloud formation from hour to hour. And it also means we can more accurately track tropical storms that might develop into dangerous hurricanes. Even better, RapidScat's path will cross those of the other scatterometers, allowing for careful calibration of all of the instruments, so we know we're comparing apples to apples when we put it all together. There's still a lot we don't know about our planet, not least of which is what's going on in the atmosphere. But wherever the wind blows, RapidScat will soon be keeping a watchful eye out for all of us.